Assalamu alaikum. My project is of random binary search tree, that is TREAP. Now in simple binary search tree we know that every node carries a values and a single rule is followed that if you are trying to insert a value that is smaller than the root, then you should go to the left hand side as you can see in this example, and if you are inserting a value that is greater than the root, then it should go on to the right hand side. You can see it. Now note down that root is that value which is inserted first. Now in random binary search tree, a node holds a value, but it also holds a priority number that is generated randomly to every node during insertion. If you in this case it is min heap, so the root's priority should be the smallest among all the children. If it is max heap, then your root's priority should be the largest among all the children. This is min heap, priority should be smallest, 35 is smallest. We are trying to insert 6,77. 6 is smaller than root, so it goes to the left hand side, and if 15 is greater, it goes to right hand side. You can see in this example same tree with focused values, just to show that our tree is following the binary search tree property, that is, you can see smaller in left and greater than in right. Same tree with focus priority, just to show that heap property is fulfilled, that is, root should have the minimum priority among all the nodes. Here we have algorithm of insertion. If you are trying to insert a value that is none, it's simply returned because none can't be our value. If root is none, mean if our tree is empty, then the value that is going to be inserted, that is 34, make that a root, and in a bubble up function assign its priority. Now bubble up is our main private function that is checking tree heaps property and also binary search tree property. Like if we want to insert 40, now 40 will go, if according to the binary search tree property, 40 should go on the right hand side, and priority is assigned 105. We will check that if it is smaller than root, then we will perform rotations. In this case it is greater than root, we do not have to perform any rotations as this is our min heap. You can see in the 25 example it goes to the left hand side because it is smaller than our roots value, and priority is also greater, so we do not have to worry as it is our min heap. You can see in this example, this is an example of random binary search tree, and which is following min heap property. For more clarification, let's see this example 2, 8, 12, 3, 6. These are values are going to be inserted in our tree. Remember that our tree is none. Okay, now priorities are assigned randomly 45, 12, 36, 72 and 23 to the nodes. We will first arrange these values according to the increasing order of priorities. You can see 12 is the smallest, goes to the first, and 23 and so on, increasing order. Now our heap property is fulfilled. Now we will construct a tree using a binary search tree property. 8 goes first, becomes root, and now 6 is smaller than root, it goes to the left. Similarly 12 is greater, it goes to the right hand side, and so on. Our tree is constructed. Now this tree is a final tree which is following heap properties and also binary search tree property. Now algorithm of deletion. If value is none, means if you're trying to delete a value that is none, it will simply return. If root is none, means the tree is empty, it will also return. Else trickle down. Now trickle down is a main private function that is checking all the conditions of tree and tree and heap. So it will check if the value is greater than root dot value, then search for it in the right, and if the value is lesser than root's value, then it should go to the left, and then perform rotations according to it if the heap's priority is violated. We'll see in this example. Let's suppose this is our tree. We want to delete this node 6, 23. Note down we have 3 conditions. Like if the node that is going to be deleted has no children, we will simply unlink that node with our tree. If the node that is going to be deleted has only one children, we will first link that children of that node that is going to be deleted to the parent node of that node which is going to be deleted. Here we have the worst case, like if the node we are going to delete have 2 children, 2,45, 3,72. So we will check the minimum priority of the children, that is that the node is going to be deleted. In this case, 45 is the minimum priority among the children of the node that is to be deleted. So we'll connect this 2,45 with our main root, and this will be the final tree.
Now, algorithm of finding a value. Now we have two functions, search value and find. Find is our main private function and search is simply nothing but calling a find function and checking if you are trying to search for a value that is none, it's quite simply returned. In search, if find value in search is true, simply means find function found the value and it is present in the tree and it will return true, else not found, return false. Now find value. Now find value is working on three conditions. Like if f is none means if your root is none, it will simply return. Else, if the value you are trying to find is greater than the root, then it should go to the right hand side. And if the value you are trying to find is smaller than the root, then it should go to the left hand side and search for it there. And if found, return true. Search value will return true, and if not found, search value will return false. Now, to find minimum and maximum values in our binary search tree, search min value. Okay, obviously, if root is none, yeah, empty, just return while root dot right is not none. Now, this condition is basically used because what if our tree has only root, that means that is only one node will generate an error. So while root dot right is not none, means root dot right hand side is not none, because in binary search tree all the minimum values are stored at the left hand side, and in the other hand, in the other search for the given value in right, as all larger values are stored there.